Hi everyone, let's solve this problem. Valid Sudoku. Determine if a 9x9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. Each row must contain the digits 1 to 9 without repetition. Each column must contain the digits 1 to 9 without repetition. And each of the 9 3x3 sub boxes of the grid must contain the digits 1 to 9 without repetition. Those sub boxes are these. So these should be containing 1 to 9 digits without repetition, and a Sudoku board partially filled could be valid, but it is not necessarily solvable. So if it is valid with the filled numbers, then it is good. It does not have to be completely solvable. Only the filled cells needs to be validated according to the mentioned rules. That's what they are mentioning. Let's see how we can solve this problem. Let's say, for example, what they're asking, let's write the rules first. Row, column, and then sub box, right? These are the things which we need to think about. So how many rows are there? There will be 9 rows, right? Every row we have to check, like there will be 9 rows. Every row we have to check if that row has valid 1 to 9 and without repetition numbers in that particular row. Same with column, there will be 9 columns and we have to check for each column, and there will be sub box. Let's say, for example, the sub box is this, and so on, right? Every sub box, right? Let's say, for example, I kind of take each of this sub box as these, then we will be able to solve this. So for us to understand even better, let me write the indexes of these numbers, these rows, and also the columns, and then let me write the columns and rows for the sub boxes. So let's say, for example, if I take a particular cell, let's say this one, this is nothing but 4x4. So if I have to get 1x1 as sub box, 1x1 as sub box, I can just do 4/3, 4/3, which will give us, we have to take the floor value of it, which will give me 1x1. Let's say I take this particular cell and the cell value is 7,7. Again, if I do 7/3, 7/3, I'll get 2,2, right? So this is how we are kind of going to get the box index, and we know every row and column we already know because we already have the indices. So in this case, let's say, for example, so for all the rows, let's say, for example, for the first time we are like working on only rows. Let's say for the 0th row, it will be a set. I have 5, 3, 7. Is it valid? Yes. Second row, 6, 1, 9 and 5. There is no repetition. Let's say, for example, in the second row, 9, 8, 6. Let's, for example, consider there is a 8. 8 is already present in the cell, right? So if it is already present, that means it's invalid. Whenever it is invalid, we have to kind of return from there itself instead of going forward. Same thing applies with column. Columns also will have, every column will have a set, and for every set we are going to check if it has unique values or not. And same thing applies with the sub box, and for sub box we are going to get the key from row by 3, column by 3, right? This will be the key for that particular sub box, and then we are going to check within that sub box if there is a unique element or not. Now let's try to write the code for the same. So initially let's define rows with map, because we are going to have like key will be row index and the value will be a set. Same thing with the columns, and same thing with the boxes. Now we are going to iterate over all the cells. They have clearly mentioned that it will be only 9x9 Sudoku, so we don't have to worry about like changing this as a constant. It will always be 9. And how do you identify if a particular value is given or not? If it is a dot, the value is not given, we don't have to make any operation. So if board of ij is equals to dot, then continue, we don't have to do anything. Let's say for example, if rows dot get of that particular row, let's say for example 0th row, rows dot get of already has a element is nothing but board of ij. If it already has it, then we have to return false. Same thing for the column, same thing for the boxes. One additional part here is that we have to check if there is a value initially, right? Because we are creating a map. Let's say for example we did not insert of any element in the first row, so it might cause issues over there. So basically we have to ensure that we do have some value in that particular map, then only we kind of check if that particular value is present or not. If columns dot get of j has element, then also we will return false. Same thing applies for boxes. For boxes dot get, so for boxes we know that we are going to create a box key. Box key will be math dot floor of I/3, and also math dot floor of j/3. So this is the box key. So we are going to check if that particular key is present, and if that particular value is already there, then we are going to return false, right? And since I mentioned, so basically what I'm trying to say is, for example this is my 0th row, there is a map of key value but it does not have anything, right? We have to initialize it to a set if there is nothing, right? This part we have to do, and before getting a value from this particular index we have to check if there is a set or not, right? So those are the checks which we are adding. We are checking if there is a set already or not, to check if that element is present or not. Now we also have to check if rows dot get of I is not present, we have to rows dot set of I comma new set. This is what we have to do. And if not of calls dot get of j, then we have to set new set. If not of boxes dot get of box key, then we just have to set the box key comma new set. So these are just the validations I am writing. And now what we have to do, if it is already present, we are kind of returning false from these 3 rows, columns or boxes, right? Validations are done. Now we will have to add these elements to our sets. Let's say for example boxes dot get of I dot add, what do I have to add? I'll have to add element. So let's say for example I'm iterating from here. I got 5, right? The indices are 0 0. So in this case, this is row, right? In row, inside the set, I'll have to initialize the set first, and then I'll have to add 5. And for the column is also 0. Then I'll have to because there is no value initially, I'll have to initialize and add 5. And inside the box, it will be 0 0. In this, I'll have to add 5. Now I go to this particular value. Row is 0, column is 1. So for row, I will add 3, and for column, again it's in the first column, so I'll have to just add it at first column. I'll add 3. And if you observe, even though it is 0 1, by 3 by 3 will give us 0 0. So in the same set for the box, I will add 3. This is how we are adding. So now if you see here, we are depending on I for this, we are depending on j for this, and we are depending on the box key for this. Box key is nothing but I by 3 and j by 3. So we are going to add it to the rows. So sorry, this is for rows. Now we will go add for columns. Columns, we will choose the j and add element, and then boxes dot get of box key, and for the box key we will add the element. Once this is done, if we have completed the entire iteration, that means it is a valid one, so we'll return true from the end. And this is how it works. You can kind of combine these checks. It's up to you. So yeah, now let's try to run this. Yes, it's successful, so let's submit it. Cool. Let's try to understand the time complexity of this. Time complexity of this solution is simple: 9 cross 9, n cross n if you take n as 9, right? And let's also understand the space complexity of n square. N into n is n square for the time complexity. And for the space complexity part, if you see, there are 9 rows, right? 9 rows, every row has 9, so 9 into 9 for rows, plus 9 into 9 for columns. For boxes, it will be just 1 2 3 4 5 6 7 8 9 boxes. But overall, if you consider, it will be like n square plus n square plus n, because we are considering n as 9, right? So it is n square. But if n is equals to 9 all the time, this is all constant, right? Because we are kind of using only these many cells space, that's it. But yeah, in that case also the time complexity will be big O of 9 cross 9, and same thing here, it is n cross n, nothing but big O of 9 cross 9. I hope the solution is clear. Thank you.